So hello guys, in this video we will discuss about the advanced encryption standard AES. So many algorithms have been developed for encryption and decryption of the sensitive data. Among these algorithms, the most commonly used algorithm is AES. So AES is a cryptographic standard that is used to encrypt data to keep it secure. So actually AES is a block cipher. So first of all we will understand what is the block cipher. So let's see. Encryption algorithms are mainly divided into two parts, the block cipher and the stream cipher. So block cipher is an encryption algorithm that takes a fixed size of inputs. Like assume that it takes B bits and it will produce a ciphertext of B bits again. The best examples of block cipher is electronic codebook, cipher blockchaining, cipher feedback mode. You can see the electronic book code. So here P1, P2 up to Pn are the block of plain text, and using this algorithm and key we can produce a ciphertext like you can see that C1, C2, Cn are all ciphertext, and using reverse process we can also decrypt it and gain our plain text block. So that's how it works. So there are few drawbacks also that we can send only small text because big text has some repetition in plain text. So attacker easily find pattern of the encryption. So now we will see more about AES. So AES uses the 128 bits of plain text. Actually, AES uses a 4 cross 4 matrix as input. So we have to convert 128 bits of plain text into an 4 cross 4 matrix. And how we'll do it? So we can divide 128 bits divide by 16, so it will give 8. So each cell of this matrix will have 8 bits, means 1 byte. So that's how we can create a 4 cross 4 matrix of this plain text. So here each column will represents one word. So we will use term word as 4 bytes. So whenever I say one word, so it means it is indicating 4 bytes. So here if you say this is zeroth word, then this is the zeroth byte of that word. So that's how it works. And AES consists of multiple rounds for processing different key bits. Like if you take 120 bits key, then encryption process will happen in 10 rounds. If you take 192 bits key, it will happen in 12 rounds. 256 bits key, so it will perform 14 rounds. So AES algorithm takes two inputs. So we saw that in last slide that it takes a 4 cross 4 matrix of plain text, and it will also take the encryption key, which is also 4 cross 4 matrix. For encryption in each round, the following four steps will happen. So first step is substitute byte, shift rows, second is third is mix column, and fourth is add round key. So this third mix column will not happen in the ninth round. So you can see the brief structure of this encryption system. So if you give the plain text, first it will perform pre-round transformation, after that round 1 up to round n, and finally it will generate the ciphertext of 128 bits. So first of all we have to understand how to expand our key. So assume that we have 128 bits of key, so it will perform 10 rounds and we will need total 44 words. So we have to expand our 4 cross, we have to expand our 4 words into the 44 words, and how we will do that and why 44 words. So you can see this that pre-round transformation will need 4 words, round 1 will need 4 words, and according to that 10 round will need total 40 words and plus 44 for the pre-round, and that's how we have to expand our key into 44 words. So how we can generate this 44 words? So this is our 4 cross 4 key matrix. So this first column represents first word, this second column represents second word, uh, and this will perform with the G function. So what is G function? So I have elaborated this in this diagram. So first of all, what happened that this W represent is all words. So first of all, the this function performs a 1 byte circular left shift. So B0 goes here and B1 goes here. So it performs 1 byte circular left shift. After that, using S box, it will perform the byte substitution. So we will see what is the X box in the later half of the video. But now assume that using S box we can substitute these bits. Now finally, after changing these bits into B1 dash, B2 dash, B3 dash, we have to uh, XOR this array with this rotation array. This rotation array consists of these 4 bits. The most significant bit is R const, and this value will change according to the number of round, and the last 3 digits of this array will always remain 0. So how we can calculate the R constant value? So we'll see that. So for first round this will 0 1, for second round 0 2, third round 0 4, for fourth round 0 8, and 10 round 36. So we can generate this using the Galva field 8. You can see that x1 minus 1 is equal to x0 mod prime 1, x2 minus 1, x1 mod prime is x. Here prime is x4 plus 1 plus 1. So we have used Galva field 8 for generating this value. So according to the round, our constant value will change, and it will generate the W dash, the other words. So uh, uh, we can do this and generate all 44 words. So that's how we can generate and expand our key. So now we will see the 4 steps of the AES. So the first transformation function of AES is called as a substitute bytes. So before that we have to know what is the S box. So AES defines a 16 cross 16 matrix of byte values called an S box that contains a permutation of all possible 256 8-bit values. So the input matrix of the substitute byte is a XOR of plain text matrix and the add round key, and the output matrix of every transformation function is called an state array. So suppose this is a state array, and suppose we have to substitute this cell as 2 comma 2. So suppose it represent as the following 8 bits. So we have to divide these 8 bits into the two parts. The first 4 bits represent the row in S box, and the last 4 bits represent the column in S box. We have to convert this binary value into the hexadecimal value, and this hexadecimal value will show us the row and the column value. Now we have to substitute cell with this cell, which is indicating by the row and column. So we have to perform this on every cell, and we are done with this step. Now the second step is called the shift rows. It is also called as a forward shift row transformation. The input of shift row is the output of substitute bytes. We have to follow these 4 rules. So we have to perform 0 byte circular left shift on the 0th row. You can see that we have to perform 1 byte circular left shift on the row 1. According to that, we have to perform 3 byte circular left shift on the third row, and we are done with this step. So now we will see the third transformation function. So the third transformation function of AES is called the mix column. This operation operates on each column individually. The input of this transformation function is the output of previous round, which is the shift row function. For this step, we need one predefined matrix, and we have to multiply each column with this predefined matrix. Now we'll see how we can perform multiplication. So suppose this is a predefined matrix and this is our state array. So we will perform a matrix multiplication between the first row of predefined array and the first column of the state array. But here we will not use the plus operation, we will use the XOR operation between them. So firstly, we can take this example. Uh, so first hexadecimal values are converted into the binary numbers. You can see that 02 and 87 we have to convert it into the binary numbers. Now this binary value is mapped with the Galois field 8. You can see that we have mapped this value with the Galois field 8. After mapping, we can see the result that if we map the 87 with the Galois field 8, it will generate x7 plus x2 plus x plus 1 value. Now, after generating these values, we will perform multiplication between them, and we will use the modulo 2 operation with the result, because we are using the z2 field, so we have to perform the modulo 2 operation. So after performing modulo 2 operation, this value will cancel out and this will be the result. And again we have to convert it into the binary. Like you can see that if we have x4 x2 plus 1, then we can convert it is like in this way to binary. So we have to do this for every numbers, and after that we will have the four values, and we have to perform XOR operation between them, and finally this result will come. So the first cell of our matrix is generated. So if we want to generate this cell, we have to perform this matrix multiplication between the second row of the predefined matrix and the first row of this state array, first column of this state array. If we want to generate this third value, then we have to perform the multiplication between the third row of predefined matrix and the first column of the state array. So similarly, we can generate all these 16 cells, and we are done with this mix column step. So the fourth step is the add round key. So it is also known as the forward add round key transformation. The input of this function is the output of mix column function. So in this operation, we will perform a XOR operation between each byte of this state array and the round key. You can see that if we want to generate b2 slash b, we have to perform XOR operation between a2 slash 2 and k2 comma 2. So similarly, we can generate all values. So this is the easiest step, and one thing that we do not perform mix column operation in the 10th step, and after performing this 4 step into the round 10, finally we will get our encrypted cipher text, and this way we can encrypt our plain text into the cipher text, and using the reverse process we can also decrypt this. So this is how AES algorithm works. So thank you for watching this video.